Okay, so today we're going to talk about side, 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 and side angle, side triangle congruence theorems. And it's just two different theorems that we're able to use to prove two triangles congruent. So now would be a great time to get out your note packet that you guys have for this week and flip to the 4.5 notes. And just as a side note, you guys did have homework due today, and unfortunately, I'm not there to check and see if it was done. So what I want you guys to do by the end of the day today, so Wednesday, go ahead and take a picture of your completed homework and upload it to Google Classroom through the assignment on Google Classroom. So where we were talking about whatever the notes we did on Monday were, I can't even remember right now. It's dated 11/2/2020, like classwork and homework. Go ahead and upload a picture there so we can go ahead and check and see if you did it. And if you haven't done it, that gives you the rest of the night tonight to get it done. And then after that, we won't be accepting late points, okay? All right, so we're going to start off by talking about side, side, side congruence postulate. And that basically says if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are going to be congruent. And I cannot spell. There might be a lot of typos today. I'm just letting you guys know. Okay, so if three sides on one triangle are congruent to three sides of another triangle, then those two triangles are going to be the same or equal or congruent. Okay, so we're going to look at these two triangles down here. We have triangle MNP and then QRS, and we see we have these different tick marks. Okay, so we have the one here, and this is like being funky and weird. Can you see it now? There we go. We have one here. We have one here. We have two here and two here. And then I'll leave the three in like that maroon color. All right, so we see that it's asking us about MN. MN has one tick mark, and the other triangle QR has one tick mark. So MN is going to be congruent to QR. NP over here has two tick marks, and RS on the other triangle has two tick marks, so NP is going to be congruent to RS. And then lastly, PM, which has three tick marks, is going to be congruent to the three tick marks on QS, so PM will be congruent to QS. So since all three sides of both triangles are congruent, so MN is congruent to QR, NP is congruent to RS, and PM is congruent to QS, then the triangle MNP is going to be congruent to the triangle QRS. Okay? So in example 1, it's asking us which two triangles are congruent by the side, side, side congruence theorem. Complete the congruence statement. So what I want you guys to do is look at your three triangles there and determine which two triangles have the same amount of hash marks, if that makes sense. So make sure, like, you see in the first triangle, FG has two hash marks, and you see in the second triangle, it also has two hash marks on TB. So that would be one of your congruent sides. So making sure that those triangles match up, and we'll go over it. So it's going to be triangle T or FGE congruent to TVU, and here's why. All right, FG has two tick marks right here. Okay, we look here. Okay, TV has two tick marks, so that means those sides are congruent. And we come over here, and none of the sides on this third triangle over here have two tick marks. So there's no way that this triangle, FGE, is going to be congruent to BCD, okay? They already don't have this one of the congruent sides, so there's no way that these two can be equal. All right, continuing to check, I see that GE over here has three tick marks. And when I come over to my second triangle, VU also has three tick marks. So that's another indicator, okay, we're on the right track for FGE and TVU. If I come over to triangle BCD, I see that one of these sides also has three tick marks. But we already said since FGE has a line with two tick marks, And BCD has a line, but there are no 2 tick marks on that triangle. That FGE cannot be congruent to BCD. So even though they have one congruent side, they need all 3 sides to be congruent. Lastly, on FGE, I see from F to E has 4 tick marks. And I also see on TVU that TU has 4 tick marks. So since I have 3 congruent sides between FGE and TVU, those are the 2 triangles that are going to be congruent. And BCD is not congruent to either one of them. All right, so for example 2, we see we have a dreaded proof. Oh no. So we're just going to take it one step at a time and talk through it together, okay? So it says that T is the midpoint of SU, TV is congruent to UW, and TW is congruent to SV. Complete the proof and prove that the 2 triangles are equal to each other. So they give me a lot of good information in my given statement. So the first thing I'm going to do is I'm going to go ahead and mark up my picture so I can see what's going on a little bit better. So the first thing it tells me is that T is the midpoint of SU. Remember, we said the midpoint is a point that cuts the line segment in half. So if I'm looking, SU is this whole thing right here. And I know there's numbers on the end. It might be hard to see. Maybe I'll try it in a different color. There you guys, you can kind of see it in red right there. Okay, so SU is that whole segment right there. And it says T is the midpoint. So that means from S to T is going to be congruent from T to U. Okay, so T is my midpoint. It cuts SU in half, so ST is congruent to TU. All right, it also gives me that TV is congruent to UW. So TV and then UW are also congruent, so I can mark those with 2 tick marks. And then lastly, it gives me that TW is congruent to SV. So from T to W and from S to V, those are congruent to each other. So this lovely proof gave us 3 things given right off the bat. So we have 3 things that we can mark as given and get 3 points. All right, so T is the midpoint of SU. That was something we were given. So I can go ahead and type given in. TV is congruent to UW. That's another thing we were given. Oh, this is so easy. And then TW is congruent to SV. That is also given. Okay, so those are my 3 gimme points. Now in step 4, it says ST is congruent to TU. Well, we knew this because I'm looking for my highlighter. Okay, we knew this because T was the midpoint of SU. So let me see, is this going to work for me now? Okay. T was the midpoint of SU. So that means that ST is going to be congruent to SU. The highlighter tool is not working very well. You live and you learn as you do these things. Okay, so since T was the midpoint, that made these 2 congruent to each other, so we could use the definition of midpoint over here as our reason. Okay. So I look, okay, TV is congruent to UW. That's looking at my green sides right there. TW is congruent to SV. That's my pink sides right there. And then ST is congruent to TU. So I have all 3 of my sides of my triangle, and TVS is congruent to all 3 sides of my triangle in TWU. So that means that triangle STV is congruent to triangle TUW by the side triangle congruence theorem. And I'm just going to abbreviate. Okay. And remember, we talked about when we name triangles, we have to make sure that they match up. So maybe when I named my triangles earlier, they weren't quite accurate. But just to go back, STV is going to be congruent to TUW, and that's because those sides line up with each other. All right, so for example 3, we want to know are triangle STU and triangle IJK congruent by side, side, side. So now I want to take a look at this, and it looks like I have right triangles because I have that perfectly vertical line and that perfectly horizontal line that cross each other. We said when we have vertical and horizontal lines that cross, they're perpendicular, so we do have a 90-degree angle. So I can go ahead and I'll just kind of mark that to give myself a note that these are both 90 degrees. Now I need to check and see if my sides match up. So I'm going to start from T to U down here. Okay, so there's from T to U, and I'm going to count down my units. So I'm going to just count the lengths of the side. It's the easiest way to do it. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this side is 9 units long. All right, now I'm going to check my other easy to count line just right off the bat because that's the easiest thing for me to do. So I'm going to go from U to S, and that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. So I'll write a little 10 down here. All right, now I need to find the length from T to S. And this is when we're going to use our Pythagorean theorem yet again. So our a squared plus b squared equals c squared. So I'll give you guys a second to set that up. Remember, your c value is always going to be the value across from the 90-degree angle. So in this case, you're going to be looking for c. Okay, so I went ahead and plugged my stuff into the Pythagorean theorem. I called the side with 9 my A, and then the side with 10 my B. So I went ahead and did 9 squared plus 10 squared is equal to c squared. 9 squared is 81, and then 10 squared is 100. And when I add those together, I get 181 is equal to c squared. But I'm not done. I have to take the square root of both sides to get c by itself. And I get c is equal to about 13.5, 13.45, whichever you guys wrote down. So those are the sides of this triangle. Now I need to see if the sides of my other triangle match up. So I'm going to go ahead and do the same thing I did for triangle STU. So I'm going to count down or count from J to K. So I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm just going to double check and make sure I counted that right because I had something in the way. Okay, so this went across 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this side is 9. And maybe it might be easier for me to put this one in red since, hey, I see on my triangle STU, my red side had 9. So it might be an easier visual cue for me to put a red over here so I can see that they match. Okay. And now I'm going to count from K to I. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so this side has 10, and I'm just going to leave it in yellow because my yellow side on my other triangle had 10. So I don't have to do the Pythagorean theorem all over again. I know that these are my two sides, and the side across from my 90-degree angle is my c value. So I'd be setting up the same exact equation to solve for a number that I've already found. So this side's also going to be 13.5. And yep, triangle STU is going to be congruent to triangle IJK because TU is congruent to KJ because US is congruent to KI, and lastly because TS is congruent to ij. So these two triangles are congruent by side, side, side. So go ahead and take a second to do example 4 and put your answer into the Edpuzzle option over there. So this was indeed yes. Okay, so QR is congruent to SR, and then QP is congruent to PS, and they share a side PR. Well, this sounds a little silly, but PR is congruent to itself, right? If I had two lines called PR, they're going to be the same. So this side is congruent to itself, which means that these two triangles are going to be congruent by side, side, side. So now we're moving on from side, 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 and we're going to talk about side, angle, side congruence postulate. So basically, side, angle, side is exactly how it sounds. You're going from one side to an angle to another side, and if that side and angle and other side match up with another triangle, side, angle, and side, then those two triangles are going to be congruent. That was a mouthful, so let me go over it again. If two sides and the included, and there we go, included angle of one triangle are congruent to two sides and the included triangle of a second triangle, then the triangles are congruent. So let me just say it one more time. If two sides, okay, so you have two sides coming together like this, and the included angle, so the angle between the two sides, we kind of talked about this on Monday, okay? The angle between the two sides, if the two sides and the included angle of one triangle are congruent to the two sides and the included angle of a second triangle, then the triangles must be congruent. Okay, so if you have two triangles and they have these two sides are congruent and the included angle between the two sides, then the two triangles will be congruent. All right, so looking at our picture, PQ has one tick mark and WX has one tick mark, so PQ will be congruent to WX. Angle Q has an arc mark and angle X has an arc mark, so angle Q is going to be congruent to angle X, and I don't have a fancy angle thing on my laptop, so just bear with me. And then QS has two tick marks and XY has two tick marks, so QS is going to be congruent to XY. Okay, so I have my side PQ, my angle Q, and then my side QS. So let me go ahead and go over that. My side PQ, my angle Q, and then my side QS. Ooh, and that was not what I thought it was going to be. There, it's going to be in yellow, okay? So my side PQ, angle Q, side QS, and then I have my side WX, my angle X, and then my side XY. All right, so my side, angle, side are congruent in both triangles. Then triangle PQS is going to be congruent to triangle WXY. And be careful, I am going in order, making sure that my triangle names match up. So I'm going from P to Q to S. Okay, line PQ is congruent to WX, so if PQ is here, WX has to be here. Angle Q is congruent to angle X, so if Q is in the middle, X is going to go in the middle. And then Q to S is congruent from X to Y. So from Q to S, my second and third spots, X to Y need to be in my second and third spots. So my triangle name is all good to go. All right, so similar to what we did on the front side of the sheet, in example 5, it's asking us which two triangles are congruent by side, angle, side. So which triangles have two of the same sides and the angle between those two same sides are equal as well. Be careful because I see in all three triangles, they all have one arc mark and the same angle, okay? All right, so the triangles that are going to be equal to each other are X, Y, and W, and then it should be to K to J. So I even screwed up there. Let me fix that. IKJ. And here is y. So from x to y, okay, I have 3 tick marks. And from I to k, I have 3 tick marks. And you'll notice in this third triangle over here from C to B, oh, I do have 3 tick marks too. So that could be possible. So all 3 triangles are still in play. Well, now from Y to W, I have 2 tick marks. So I'm checking my sides first. From K to J, I have 2 tick marks. Oh, and then from B to D, I only have 1 tick mark. So that kind of takes B, C, D out of the running, okay? It has a side with 1 tick marks. The other 2 triangles have sides with 2 tick marks. So that means that YW is congruent to KJ, but BD isn't congruent to anything. So now that I know, oh, in my first 2 triangles, I have 2 sides that are congruent, I want to make sure that the angle between those 2 sides are also congruent. Because if that angle isn't congruent, then I don't have congruent triangles by side, angle, side. Well, okay, this angle right here has 1 arc mark. Oh, so does this one. Okay, there's no arc marks with a tick mark or anything. So both of those angles are congruent, which means that XYW is congruent to IKJ by side, angle, side. So in example 6 is another proof, but this proof is also kind of like the one we did about side, 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 except this time it's about side, angle, side. So what I'm going to do is I'm going to give you guys a couple minutes or however long it takes you. We can just pause the video and work this out and answer it in Edpuzzle. But it gives us 3 things: that TUW is equilateral, which means that this triangle right here has 3 congruent sides, okay? And it gives me that UV is congruent to TX. So from U to V, and you can barely see it, it's in yellow, from U to V is congruent to T to X. And it also gives me that the angle WTX, okay, so from W to T to X, so it's going to be this angle right here, is congruent to angle from V to U to W. All right, so I've marked up my drawings. You guys can do the same. So now that we have everything marked out, we can give our reasons. Again, we have 3 givens, so those are our 3 gimme points, and then we need to complete the proof. So I'll give you guys a second to do that. Okay, so we marked down all of our givens, okay? So triangle TUW is equilateral is given, UV being congruent to TX was given, and then those 2 angles being congruent was given. My 4th statement says TW is congruent to UW. So those are both sides in my equilateral triangle. So we know that these 2 sides are going to be congruent because we have an equilateral triangle. So that's just definition of an equilateral triangle, and that should be on your yellow definition sheets. And then lastly, okay, well, we see our 2 triangles, TWX and UWV. They have XT is congruent to VU, WT is congruent to WU, and then we have our angles in between our 2 congruent sides. So then we have those 2 triangles being congruent by side, angle, side. All right, so now, oh no, we're given all of this diagram and we have to prove that the 2 triangles are congruent. Oh, but we aren't given any statements or reasons. And this is something we haven't done yet. We haven't worked through a full proof where we have no statements and no reasons. So it might be helpful to do this together. All right, so I'm given a lot of stuff about this triangle just from the diagram. So I'm going to kind of write them down off to the side so I can keep like a running list. All right, so I see that in my diagram that AE has 1 tick mark and ED has 1 tick mark. So that means that AE is equal to ED. Okay, and that is given because the diagram gives that to me. So when I write that in my proof, my reason will be given. All right, it also gives me that BE is equal to or congruent to CE because both of those lines have 2 tick marks. And that's it for my given statements. So I'm going to go ahead and fill those in. So AE is equal to ED, and BE is equal to CE. And both of those reasons, well, the diagram gave it to me, so they're given. All right, now I want to prove that these two triangles are congruent. So I have two sides are congruent. I need to either prove that the third side is congruent by side, 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 which we don't have, so I'm not even going to go down that path. Or, oh, I see that they have these two angles labeled 1 and 2. So that gives me a hint that I might need to use side, angle, side to prove these two triangles congruent. All right, well, it looks like to me that 1 and 2 are going to be congruent to each other, but it's not given to me by the diagram. Remember, we said that angles that are across from each other are going to be equal because they're vertical angles. So I can write angle 1 is going to be equal to angle 2 as one of my statements, but the reason isn't going to be given. It's going to be the vertical angles theorem, or definition of vertical angles, whichever you prefer. Okay, so 1 and 2 are across from each other in the diagram. I can see that. But the reason I can say angle 1 is equal to angle 2 is because they're vertical angles. So now, BE is congruent to EC, AE is congruent to ED, so I have my two sides, and my angle between those two sides are also equal, so I can say the two triangles are equal by side, angle, side. So triangle AEB is equal to triangle DEC, and that's because of the side, angle, side triangle congruence theorem. So that one wasn't as bad. It was a little daunting because it was all empty and we haven't done one like that, but that wasn't awful. Okay. So example 8 is another one where we have two triangles and we need to see if they're congruent by side, angle, side. So I see I have right triangles. Maybe I need to start off by counting my sides. Okay. So I'm going to start off in FHG. And I'll know that these two triangles are equal or not if two sides are equal, okay? And then if two sides are equal, then we have to determine if the angles are equal. But I'm going to start off by finding the lengths of my two sides. So let me start on triangle FHG. So from F to H is right here. And when I count, my line didn't go all the way. When I count, go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I have a length of 9 over here. From H to G, my lines are really starting to get laggy now. Let me see if I can get, there we go. I go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I have 9 and 9 over here. Now I need to check if those two sides are equal to these two sides over here. So from B to D and from C to D. So I'm going to start from C to D. So I get 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so far so good. Now from B to D, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 isn't equal to the other side here, okay? This is the only 10 we have. So these two triangles, there's no way that they can be congruent by side, angle, side. Even if the two angles, okay, this is a 90-degree angle and this is a 90-degree angle, but since 9 maybe is equal to 9, but 10 is kind of here on its own. There's no way that these two triangles can be congruent by side, angle, side. All right, I know that was a little lengthy, and I know it's not ideal doing it over Edpuzzle, but please email Mrs. White if you guys have any questions. I have access to her email too, and we are readily available to help you. And if you need further explanation on side, 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 or side, angle, side, you can set up a Google Meet time with me or Mrs. White if she has time, or yeah, we can figure it out as we go along. I'm going to be out at least Wednesday and Thursday. Hopefully after Thursday I should be back, but this is going to how the next two lessons are going to be. So you guys can feel free to email if you have questions. You guys still do have homework, okay? So we did the 4.4 notes together. You have the 4.4 worksheet and you're able to turn it in via Google Classroom. So the 4.4 worksheet is still going to be due by class tomorrow. So those need to be turned into Google Classroom by about 10 o'clock tomorrow morning, and we'll be checking. Okay. I will see you guys tomorrow via video and then hopefully Friday in person.